let me talk a little bit about how Xilinx is revolutionizing the 5G network. And we do it all the way from RF to core. And we're really the only company that can cover that breadth. Very few companies have the ability to do the type of RF that we do. And as I will talk about in a little bit, we're already deployed in a number of 5G networks at the moment. So in radio, we've always had strength in radio, but RF SoC is basically revolutionizing what's happening. And the reason has to do with a concept called massive MIMO. So massive MIMO is an array of antennas that allows you to beam, essentially, information to a number of different customers using the same frequency. It's called spectral reuse. And this is one of the key enabling aspects that allows the cost of 5G to be anyway tenable. So now, when we look at our current devices, basically, we're able to cover, say an 8x8 antenna with a single device. But with our new Gen 3 RF SoC device, which you can see outside, we have the capability to cover 16x16 antennas, so it takes 4 of them to do a 64x64, and it covers the entire spectrum from 6 gigahertz down, all with direct RF. So essentially, this is a radio in a chip. As I mentioned, we brought out our first generation of RF SoC about a year ago, and as I said, we're now deployed in 2 5G networks working very well. In fact, I believe we may have been the first device to carry 5G data at the World Cup over a year ago. So, with RF taken care of, we now talk a little bit more about beamforming. And beamforming is computationally very difficult. And this is where the Versal device comes in. We think that the AI engines are the ideal platform. It's the killer app to some degree for AI engines to do the type of beamforming calculations that are required. And we're really looking forward to showing that off over the next number of months. So now I want to talk about a little beyond the radio. There's been a lot of discussion about baseband and ASICs potentially replacing FPGAs. From our perspective, we see ASIC replacement slightly differently. And that's the fact that we believe that ASIC will actually be replaced by disaggregation. So how is that going to happen? Essentially, what we're going to see is the traditional baseband that used to live beside the cell tower will be broken into 2 pieces. The first is called the distributed unit, and that's going to still live relatively close to the cell tower, and that's for types of applications that require low latency. And how will that function be provided? Well, it's going to be provided by commodity servers and FPGA accelerators. And who will provide the commodity servers? Well, people like AMD and that other company that they're gaining market share against, one of those will probably have the server. But we feel actually pretty confident that we are going to be the FPGA of choice to do the bit banging that's required, and that will always be required in that type of application. A little further away, we have the central unit. Again, this is not a data center like Salil talks about it with 2 kilometers of area. This is essentially a local office in which you'll have, again, servers being accelerated by FPGAs. So from our perspective, we see a very bright future in the O-RAN standards that will be rolled out, and we think that there is an imperative as to why this will happen. It's already happened in data centers. We see the same thing happening in networks.